Good morning, afternoon, evening, everyone. It's my pleasure to start this session. In fact, the first session after our opening ceremony, if we don't count the IEEE technical committee meeting. My name is Kinshuk. I am at the University of North Texas in United States, and it is my great pleasure to introduce our keynote speakers of today. So Dr. Kaushal Kumar Bhagat, who, as you can see, he has started his video, is currently working as an assistant professor in the Center of Educational Technology at the Indian Institute of Technology, Kharagpur, India. He received his PhD from the Graduate Institute of Science Education at the National Taiwan Normal University in 2016. He then served as a postdoc fellow at Smart Learning Institute at Beijing Normal University before starting his tenure as assistant professor at IIT Kharagpur. He has published several refereed journal articles and book chapters. In 2015, he received NTNU International Outstanding Achievement Award. And then in 2017, he received IEEE TCLT Young Researcher Award. And he is currently an associate editor for British Journal of Educational Technology and editor-in-chief of Contemporary Educational Technology. With him is Professor Mike Spector. He is a professor and a doctoral program coordinator of Learning Technologies Department, which with my pleasure is within my university at the University of North Texas. He was previously professor of educational psychology and instructional technology, doctoral program coordinator for the Learning Design and Technology program, and a research scientist at the Learning and Performance Support Laboratory at the University of Georgia. He has been a long-time editor for Educational Technology Research and Development Journal, Development Section. He served there as for 10 years. He serves on numerous editorial boards. He has co-edited third and fourth editions of the Handbook of Research on Educational Communications and Technology. He was also editor of Sage Encyclopedia of Educational Technology. And he is now the Educational Technology Section Editor for the Routledge Encyclopedia of Education. He has more than 150 journal articles, book chapters, and books to his credit. He is very active in international educational technology development, and also has been a conference co-chair and local organizer for the 2011 IEEE International Conference on Advanced Learning Technologies. He has been my mentor for a very long time, and I have referred him in my research. My students have referred him, so I have a very big regard for him. With that introduction, I understand that there is a video for the keynote that will be played, and then both Dr. Bhagat and Dr. Spector will be here to answer everybody's question. I hope that that discussion really takes place, quite involved discussion, so that we all can benefit from it. So Margus, somebody will be playing that video now. Perfect. Thank you very much.
Well, in this pandemic situation, hello everyone. I hope you all are doing well in this pandemic situation. We would like to thank ICALT committee for this kind invitation to present our work related to inquiry and critical thinking skills. This project is supported by the University of North Texas NetDragon Digital Research Center. With me, I have Professor Mike Spector from the University of North Texas, who will be as a joint keynote speaker with me. And we are going to discuss our framework about inquiry and critical thinking skills, and also we will show some of the games which we have developed related to inquiry and critical thinking skills. Let us assume this is our education system. We have a set of school experiences and we have a set of real life experiences. Now the problem what is happening is that it looks like, or it is like a mutually exclusive education, which means you are not able to bring the real life experiences in our classroom, which is a very big challenge in front of us. Now, there are 4 important skills which we think need to be inculcated in our generation, or I can say young kids. First is about the creativity and innovation. Today and in the future, we are facing a lot of complex problems, not only related to the food crisis or related to the energy in different sectors. So we need our young kids to be creative and innovative to solve these problems. Second, the critical thinking and problem solving skills. That means to solve these problems with minimal effort and maximum output. Third, very important is communication. Communication in the sense, communication among the members of the team, how they are working together to solve these problems. Fourth, very important is collaboration. In this century, the problems which we are facing are complex, ill-structured. It is not only can be solved by alone a single person. We need a team of people with different background, with different skill sets, with different domain. So therefore, it is very important to nurture collaboration skills among our young kids. Mike.
Oh, okay, thanks. So we're going to focus on critical thinking because we think it brings together all of those elements. And later on, you'll see some applications that address the 2 circles of school experience and real life experience, how new technologies are bringing those together through such techniques as virtual reality and augmented reality. But our focus is on how to use any technology, new technologies to support critical thinking. And go ahead. And usually we try to bring in the audience with interaction. So normally I ask questions that are somewhat difficult to answer. The first one about the tallest mountain from base to peak is one that I have used on numerous occasions, especially in Asia. And of course, the answer we normally get is that it's Mount Everest or K2. And it turns out the drawing says from base to peak. And the tallest mountain is actually in Hawaii, Mauna Lea, but most of that mountain is underwater. So people don't realize that. And then there's a third case, if you measure it from the center of the earth, the tallest mountain is actually in Ecuador because the earth is not completely round. It bulges around the equator. And then I ask a question which most people get right that have any mathematical background or geometry background. Is the circumference of the first circle ratio to its diameter greater than, less than, or equal to the circumference of the second circle and its diameter? And of course, it's equal to. And that brings us to the number pi. And then I ask a question that has to do about infinity, so or infinite sets. Is the set of integers, negative and positive, more, less, or equally numerous to the set of non-negative integers? And it's the same order of infinity. So you have to say they're equally numerous. And then back to pi, is it a rational number? And the answer is no, it's not. And then there's one that's in another domain. Is there life or intelligent life elsewhere in the universe other than on Earth? And apart from the people orbiting the Earth, we don't know. And then there's one that there's the life elsewhere has to do with the limits of our current knowledge. And then another question is, things change over time. So the most numerous religion has changed over time. So I'll let you look up those answers yourself. But we like to build in the interaction, and we're not able to do that with a pre-recorded session, but perhaps we can do that when we meet together in the virtual environment. And then this is a framework that I've been using to promote critical thinking with my own students. And it's built around the centerpiece is logical argumentation. So an argument is a set of statements offered in support of another statement, the conclusion. And so then we have to question the support for each of those statements. And that brings us into a literature review. And when one does a literature review, it's important to make assumptions explicit or indicate which terms you're searching for in the literature review. And then I also emphasize that our conclusions are not proofs in the sense of absolute certainty. In the social science, we only establish conclusions with degrees of probability, more or less probable. So we want the strongest possible premises to support a probable conclusion. And then the next step, when we think about the future research in a dissertation, we think about, okay, we've established this little piece in the conclusion. What else do we need to know, or what else is implied by that little thing that we've established in our research project? And so that goes into future studies or the last chapter. And then we have to think about our subjects are typically people. And so we have to ask what a person is. And a person is not just a mind. That's the cognitive perspective that we focus on that, or not just a body with organs, muscles, and so forth, but we have habits, we have beliefs, we have attitudes, and various abilities that change over time, and family members and friends and other things that we do, and limited memory. So we have to take all of that into account, which makes social science research or learning research much harder than the other kinds of research that's conducted in other disciplines. So we have to remember that and remember our limitations. So go ahead. Yeah, I know I need to speed up. So this is, I'm going to make a political comment here. This is a long time pyramid from Maslow. And the general idea is you can't get to the top of this self-actualization or self-fulfillment until lower order needs are met. And the problem is we've systematically in my country not met all the lower order needs of certain populations, such as blacks. And so the very few of them reach the higher parts of this pyramid. And we're only now beginning to realize that over 400 years, we've denied certain people good jobs or good health care. Anyway, that's my political comment for the day. Black Lives Matter. Let's go forward. I'm not a politically correct person. I try to be morally correct. So all of these things that we need to take into account change over time. And some of these change quickly and some of these don't change quickly. Moods change very quickly. Emotions change from time and place and situation. But culture is more slow to change, and we're trying to change culture based on things that we're just learning. But then lots of people have to change for that to happen. But we need to take all of that into account. And so cultural differences are important, and people are doing research on cultural differences. So what works in one culture doesn't necessarily work in another. Okay. Games may transcend that. We'll see. Yeah, that's our belief. We can go on. I know I got to speed up. So this is just a quick comment. You'll have all these slides anyway. And if for some reason you need to get them, you can email either one of us. But I'm going to skip over some of these slides and just say that with the word no, what we need to take into account is a person's ability to do something that other people care about or that the individual cares about. So it has to do with ability and not just remembering facts. And so you see there's the Mew puzzle is mentioned there, and I'll go over that in a second. Go. We're speeding on to the next one. So this is interesting doing this virtually, and we practiced before with me controlling the slides, but this time Dr. Bhagat is controlling the slides. So that, there are limitations to virtual presentations. The biggest limitation is it leaves you out, but we'll try and fix that when we get to meet during the meeting. This is the Mew puzzle by Douglas Hofstadter. It started in 1979, and I used to give this to my first year computer science students. And the idea, imagine an artificial language that has 3 symbols or 3 characters, M, I, and U, and you're given the first word in this language is MI, and you're getting 4 rules. And the first rule is if the word ends in an I, you can add a U. The second rule is you can repeat all of the characters following the initial M to create a new word. All of the words in this language contain exactly one M, but any number of I's and U's. If you have 3 consecutive I's, you can replace those. I mean, if you have a U, you can replace those with 3 consecutive I's. And if you have 2 consecutive U's, you can drop those. And so the idea is, given those 4 rules in the initial MI string, derive MU using the fewest possible steps. So that's the challenge. And so the next screen shows how this might evolve in a tree, deriving various things. The MI can go to MII by rule number 2, repeating the string after the initial I. Or MI can go to MIU. If it ends in I, you can add a U. And remember, you can always apply rule number 2. And so that's a clue for computer sciences in the room. If you try to program this the way I presented it, the program is going to run for a very long time, let's say, and it's going to not stop. And the reason it won't stop is because you cannot derive MU using those 4 rules. And to realize that, that's something a person might realize if they start to build this little diagram that I showed. If you have one I, then 2 to the n gives you 2, 3 times n gives you 3. And you'll see that those 2 columns never coincide, so they're not divisible, dropping 2 U's. There's no place where they coincide. So anyway, but not many people will build that tree, so they don't realize it. So the classical definitions of knowledge, I'm going to skip quickly over this: justified true belief, or something that's certain. And neither one of those are fully satisfying. So what we deal with in the social science really are strong beliefs, going back to that probability. Do I have good evidence to support what I'm thinking? And that's closer to the Greek definition of justified true beliefs. Let's go forward. So this comes from one of my professors who was constantly reminding us that if you have the belief, I cannot imagine any other explanation except this, so it must be this, that involves a leap, and it's unjustified. Just because you cannot imagine it doesn't mean it has to be so. And then normally I try to elicit examples of people who had that belief, I can't imagine any other explanation. And then I usually tell an embarrassing story about myself because I've been guilty of that leap. Yeah, anyway, so we'll go forward and I'll skip my own embarrassments. So what is it that really matters? And so what really matters, I'm going to skip to the bottom of this slide, is that coming to know something or developing knowledge takes time. So it's really a developmental process. So if those of you that are familiar with Robert Gagne, started out as a behavioral psychologist, became a cognitive psychologist, and focused on learning and the conditions of instruction to support learning. But he never accepted what developmental psychologists, the Piaget and other folks, were talking about. But coming to know something, it really takes time, it takes experience, and it takes support and encouragement. So coming to know is important. So what we're developing, the approach we're taking with critical thinking is that developmental process. So what's involved in developing this habit of mind that involves critical thinking is the question we're addressing. Let's go on. And I'll speed up and talk faster, unlike most people in Texas. And so here's some interesting questions. What kinds of things can be known? Gagne had a point of view there. I'll skip that. What are the indicators of knowledge? Socrates had an important point that it's what you do that shows what you really believe. So actions speak louder than words. People have heard that from their mothers or fathers. And so where does knowledge reside? Does it reside in books, in groups of people, and collaborations, or individual people, algorithms, and so forth? And how is knowledge passed along? And I have that question of how knowledge is passed along with regard to non-human creatures. And so maybe we'll show a brief example in a minute. Let's go. Okay, and this is a question about knowledge science, learning science, education science. Learning science is really descriptive. It talks about limits of memory and so forth, and it's descriptive research. Education science is really prescriptive research. What kinds of things can you do with instruction or as a parent or on a field experience to promote learning? And then deep learning, I want to say that learning cognitive scientists have a somewhat different view than AI. And so we ought to recognize how people are using their words, and those need to be defined for those writing dissertations or papers, and some journals require definitions of keywords. Let's go on. So I'll leave you to discuss that at the meeting. And here's a proof for the square root of 2. The question is it an irrational number? And the reason to show the proof is to show a common way of thinking that's an uncommon way of thinking that we would like to promote. In other words, thinking backwards. In this case, assume that it is a rational number, square root of 2, and you're trying to prove it's not rational. So assume the opposite of what you believe. Well, if it's a rational number, then it can be expressed as a ratio of 2 integers, and would be, because it's in the denominator, can't be equal to 0. And then you can derive a proof that following rules that preserve the truth in this equation, you can arrive at a contradiction. And so if you make an assumption, apply rules that preserve truth, and you arrive at a contradiction, then your initial assumption has to be false. That's what's called an indirect proof, or a reduction to absurdity. So then square root of 2 cannot be rational, because if it were, it would lead to something that's false. And this lays out, this slide lays out that proof along with explanation. So we'll skip this because most of you know this, but a lot of students don't know this. And hopefully this is not showing up on the screen because I'm getting messages from different people. So this is a hierarchy that's common, and I've seen it in computer science books and also in psychology books, that builds up how knowledge and wisdom are developed. And so we go from raw pieces of data to structured data or information. And then we develop rules that apply to that information, or that might be called meta information. It's rules and principles about information. And knowledge is the ability to apply those rules and principles, the ability to do something based on the meta knowledge or the meta information or the structured knowledge that we have. So it's ability to apply that knowledge, and it's also the ability to create new rules and principles. Some individuals can do that, and we're trying to get computers to do that. And so the way people do it and the way computers do it is different. And then we have this thing called wisdom that very few people possess. We recognize it when we see it, but it's very hard to define. And part of it, definition, is knowing when not to apply a rule or to make an exception, and we call that wisdom. And sometimes it involves humor or other kinds of things, but a few people develop it. Not many machines are developing what can be considered wisdom. That may be a controversial statement, and we like to have controversies because it provokes conversation and collaboration. Keep going. I'm trying to go fast because I know we have when we did this before, we ran out of time. And so here's a way to promote critical thinking that started when I was in Norway, and Dr. Bhagat added the piece that you'll see in a diagram, that observing things that are unusual is a critical first step. So getting people to notice something unusual leads to exploration. And then if we want to promote learning, we have to present those unusual things and encourage the exploration, and then promote, well, why do those things happen? Then we're looking for a hypothesis and an explanation and thinking about the rules in a larger sense. And so that leads to some principles when you think of computer-based systems. How much learner control should be applied, when and with whom, and what kinds of control should be applied. And it's not always learner control. So sometimes we need to promote and prompt and support, and but sometimes we just let learners explore until they get into a hard to resolve situation. So we want to promote growth over time. So that's the developmental approach that we're taking. It doesn't happen in one course or in 1 year. So it takes time to develop critical thinking. So we need to start early and continually to support this through early in students' lives, and that's what's not being done. So I think it switches to Dr. Bhagat now.
Okay, so there have been many definitions were given from different perspectives. So from psychology perspective, you see by Professor Robert. So in his definition, it's a set of cognitive skills that are more specific and goal oriented. On the other hand, if we see from the philosophical definition or perspective, it's basically based on your belief. And the third part, if I can say from the educational perspective, so we all know Bloom's taxonomy, or there have 6 dimensions, where is the knowledge, comprehension, application, evaluation, synthesis, and then finally evaluation. So it comes from lower order to the higher order. So these are the 3 perspectives by which we can define the critical thinking. Now, based on that, we have a framework for the critical thinking. So now you can see that we have 4 dimensions: ability and skill, which is from the educational perspective; disposition, which is from the psychological perspective; and different levels, which is from the epistemology. And here, the time represents the dynamic nature of the critical thinking skill. And we can also say that abilities and dispositions are more correlated, or I can say that more closely to interrelated. Mike, would you like to add anything here?
No, I just want to credit, I think this diagram was initially developed by a doctoral student who's working with us on this project, Shanshan Ma, and she's been invited to attend the session. I don't know if she'll be here or not, but we have a full team that shows up on the last slide. But I think her work that consolidated all of the things that Dr. Bhagat and I had been talking about.
Right, and we have on the one side, we have a critical thinking label where from the novice, the student or the kid will become the expert, and that is correlated with the level of the ability or ability level from lower to higher. So those we can say that are correlated or interrelated. Now we have defined some of the important phases. So it is not related, we cannot say that it is linear in nature. So like first phase, we can say that is an inquiry and puzzlement. So where you are providing some kind of situations, which is some kind of innovative questions are being provided for the kids. So where they can think about a situation, and then they can identify some of the reasons that why this phenomena is happening. So answering and then asking by himself or herself. So that is one thing. And then they can explore and make their own hypothesis. So then they can create some kind of explanation and then find some kind of results or evidence for their own explanation. So there are we have different development phases, and we will show you some of the examples and how we have developed some of the games on some of the phases. Now here is the situation of a monarch butterfly. I don't know whether you know about monarch butterflies or not. So what we have created, we have a system. The system is providing some kind of examples. So the system is asking that, or providing some situation that monarch butterflies are emerging creatures, but then they are provided one situation that these butterflies fly from Canada to Mexico. So which is like, suppose this map is provided, so which is a very puzzling for a kid, that can a butterfly fly from Canada to New Mexico? Is it possible? If it's possible, then how much time it will take? So there are many pondering questions will arise among the kids by providing this kind of situation. And then there will be some kind of observation which they can make from this kind of maps or some other situation which we can provide. So there are some other kind of questions the system can provide, like or even the learner can also ask the system their own questions, like how far it is from Canada to Mexico. So the system can answer, okay, it's a 3,000 kilometers. Then it will have a follow-up question from the learner's perspective, that how far can a butterfly fly in one day? So there are series of questions which can be arise among the kids based on the situation which you are provided. So I'm just going for some example. So now here we have developed from the one 3D learning space for the critical thinking. Now what is happening here? So there is a strategy for application development. So we have a series of game-based activities. Then we have a conversational AI-based between the game and the learner. And then we have created one immersive learning environment. Or we can say that we are bringing the real-world examples into the classroom using the virtual reality. Now, this is one example of 3D learning space. I'm just giving you one demo. So this space is very easy to use, user-friendly. You don't need any kind of coding background. So the teachers can develop their own 3D environment by dragging and dropping some of the elements there. And there are some already existing assets are available by which the teacher can create their own 3D environment, which will be immersive in nature. So this is, I think it's visible on the screen. So this is one example of the 3D environment. Now, this is one example about the monarch butterfly, which we have given one element. Now, how we have created a virtual reality environment for this monarch butterflies. So here there are three different options are there. So the user number for the butterflies.
Right, and that picture is of me there. That was before several back operations, so I've lost some weight since then.
So here the system is asking some of the questions, and the user is answering those questions, the follow-up, and based on that series of questions, then user has also some of the questions which are being asked by the user. So in this way, we have created one, you can say that this is development phase which we created the first observation, how the system is provided, then the user have the question, I think in their mind, and then they can find some kind of and then they find some solutions that on some confusion and which they can discuss among their peers to find facts are correct or not, and then they can go back again to check their facts. One example. So this is a very famous game that is called a Game of India. So here there are three players. There are three observers. Now no one knows what is the observer. We have given a situation here that observers observe what is going on in the game and find out the player.
KK, can you stop your video? The audio is breaking up a little bit.
Now each observer is asking the question how they are making the decision, who is the winner. So they don't have the rules of the game. So they need to observe and find out the rules of the game. We have created a total immersive for the user. We can find out that the old gentleman is winning the game, but observers that for his winning. Observe is a and wherever the honeybee is going, honeybee is deciding the winner. And the old gentleman has a coin with honey. So it's going to him. And then so this is the scenario provided to the users, and then they can observe the situation and then they can arrive for a conclusion. Or they have that they have the new points, and the old gentleman has more points with the honey, meaning more compared to other people. In this case, we conclude that we can find out what is the rule of this. And then one example I can see on page where they can there can be some kind of situations, and the users can observe, and then they can have some kind of hypothesis for the situation or for the phenomena, and then they can observe and conclude. So therefore, we have a plan to develop a series of games taking the real world examples, and not only one phase, whatever the phases which we have discussed. So creating, it is also not necessary that for each phase we should have a different game. Either we can combine different phases together, or we can have one game for each phase. So it depends on the game developer, it depends on the content developer, it depends on the teacher also, how he wants to inculcate the critical thinking skill. So we have a plan that we will have a cloud computing where different examples will be stored. Those examples will be real world examples. Then we are also planning to have adaptive learning perspective, personalized learning features, and also effective support, or we can say that emotional support for this kind of thing. And we are going to use Mayer's principle of multimedia learning to design further games. Mike, would you like to add something?
Yeah, one other factor is the audio is working fine now, so it didn't work so well when the game was running. So I think that brings into account another constraint that varies from place to place, which is bandwidth issues. So depending on what's being shown or done, bandwidth turns out to be a problem. As it happens, that VR application that was created by NetDragon is a low bandwidth application, and some of the other require more bandwidth on the user side. So bandwidth is an additional factor. So yeah, but otherwise, yeah, we feel like we're on a positive track.
Yes. So I think we would like to thank again to all the participants, and we hope we will meet virtually during our keynote, and we will definitely try to answer your queries, and also we'll get some good constructive feedback to improve our framework, and also some ideas to develop critical thinking skills. So this work is not possible without other members of this team. So these are our team members: Shanshan, Professor Lin, Jinglen, Xianqing Gu, Professor Hong, Vico Yang from NetDragon, David from Mr. Cambridge, Professor Rodney Linson from UNT, and of course Jonah, who is an independent consultant. So thank you very much. Mike?
Yeah, thanks. Yeah, you can show your video now, but we look forward to meeting you virtually in person during the conference.
Yes. Okay.
Wonderful. Thank you very much for this. And I invite Kaushal to explain that game as he just mentioned in the chat. So go ahead, Kaushal.
Yeah, so sorry about the audio because of the Actually, this game is about the 3 players and 3 observers. Basically, the observers need to find out the rule of the game. Nobody knows what is the rule of the game. So you can find out that the 3 players are playing and there is a honey bee. So wherever the bee is going, so the bee is deciding the winner of the game. So you can see. So that is the observation, which we have said the first stage of the critical thinking. And then you can find out that the old gentleman is winning many times. Then what is the reason? Because he was working on a bread factory or something, so honey was coated on his body, so many times the bee was coming to him, so that's why he was winning maximum times as compared to the other players. So this is the basic idea about the game of India. You can find out more information on the internet, and this we have created a virtual reality experience where the student or the user can experience, and then they can find out and observe that what is going on, what is the rule of the game. So this is basically the fundamental idea behind this game. So if you have any questions, so we are ready to answer.
Wonderful, thank you. So yes, this is now discussion time. Anybody who has question, you can either just type the question or just enable your microphone and you can talk. Let me start with the first question. So I really appreciated the way you explained how critical thinking development can be supported. So here is my question: how do we support the development of the critical thinking and other 21st century skills from early stages to adulthood over longer periods of time, and how should the support mechanisms change to remain relevant?
Mike, would you like to go?
You decided to ask a hard question. Go ahead, KK. You get the hard
No, please go ahead. No, please. Yeah, please, Mike.
Well, one thing we noticed when we were doing the literature review and we were looking for examples of efforts to promote critical thinking, there were very few that really started early. And the ones that did start early were typically limited to a single interaction that might be 1 unit or 1 hour's effort. And then when we moved to college level students, there was really hardly any effort at all developed in support of critical thinking. It used to be that college students would be required to take a course in logic, which would be one piece. It's in sort of the middle of our framework, and that's no longer required in most places. Except at the University of Norway, I don't know if it's still true, but the University of Bergen in Norway, the only required course for doctoral students was a philosophy of science course, which basically promotes critical thinking in terms of science. But when we presented this to NetDragon, we argued that it needed to start early, and we were thinking about 3rd grade level, and because that's where kids in the United States begin to lose any advantage they might have had with mathematical skills to other countries. And DJ, the CEO of NetDragon's reply was even younger. So he thought that it needed to start younger and be developed systematically over a period of years. And so our framework is not meant to be linear, but it's meant to be applied in cycles and repeated for years. The problem is it doesn't show up in hardly any curriculum or curricula in the United States. There's a lot of people saying we should do it, as we showed in the 21st century skills. But when you look at curriculum development and curricula, there's hardly any evidence to support critical thinking. The other thing I just want to say briefly is our notion is when you start early, we've been teaching kids to get the answer right. So we reinforce getting it right. But learning really often occurs by getting it wrong. So we don't want to even say yes or no early on. We just want to keep asking questions and try and engage the child in an exploration and sort of nudge the child towards the right answer. So in the Game of India, the first version that we tried to show was, how is the winner determined? And it's determined by a fly lands on a coin, and the person is walking around several times and finally arrives at how the winner is determined. But then the harder question is, and we just asked the question, why did that old guy keep winning and nobody objected? So that's a harder question. That requires some exploration and knowledge about the people playing the game. And so by the time they get to that point, we think they're engaged, and they're going to engage in an exploration. I don't know if that answered your question, but maybe it's a start to get other people involved in the conversation. And then Nian Ching has a question in the chat box. Go ahead.
I just want to add one thing, like in our classroom, actually, we are not enough motivating the students to ask a good question. So asking a question will be a very important task when they are looking for some new phenomena or some puzzling ideas. So that will be very important part. So we must promote the student to ask some questions. So that will be the initial point. And also in the curriculum also, like I remember when I was a student in mathematics, so in grade 8, we used to have a chapter about the logics, but now there is no chapter about logics in the mathematics classroom. So how we can integrate in curricula also, that is also very important part. So which will transfer this thing.
Yeah, Nian Ching's question in the chat box is how to assess critical thinking skills, which is a good question. And there's a couple validated tests for critical thinking that are widely used, called the Cornell test, one for adults and one for children. And it turns out a reduced version of the Cornell test was used in a study in Taiwan that reduced it, I think, from about 79 questions to about 49 questions for kids around the 3rd grade level. And then at the East China Normal University, they took that reduced version of the Cornell test, Innes's test, and created a game, an exploratory game, where they're trying to find a friend in through a maze of rooms. And to exit a room, the person playing the game has to answer one of those 45 questions. Oh yeah, so 3rd grade. Okay, yeah, great, yeah. Thanks, Nian Ching, for that clarification. And they reduced it, try to focus on the core of the critical thinking aspects. And so right now at East China, who's some of the partners we mentioned in the last slide, we're trying to see if the results of playing that game correspond to answering on paper those 49 questions. We don't have the results of that effort. And the other thing we're trying to do is besides the lack of curricula to support critical thinking, is teacher training. So right now, the doctoral student, Shanshan Ma, is completing her dissertation at UNT, and her last question is, do middle school teachers especially, think about critical thinking in the way that we framed it in the discussion that was presented? And we don't know the answer yet. That's still underway. So thanks for that question, Nian Ching. You always have great questions.
What is the name of?
There is a question from Aparna. Says, how do you measure the critical thinking how do you measure the critical thinking in such games through online medium?
Ooh, I didn't quite understand that.
How do you measure the critical thinking in such games through online medium?
Oh, well, right now, though, as far as we know, the only way to do it online is to create a online version of the validated test that was developed at the Cornell for kids, or by playing that game that was developed at East China Normal University. And the people who developed the game at ECNU have moved on to other projects. So we're trying to resurrect that game right now, so we can do the validation study to see that they're combined. But I would argue that we want to use multiple indicators. So we also want to use test scores and grades, and also look at longitudinal studies that see, do more people now pursue careers in challenging fields and STEM fields, for example, but it's not just STEM. So it's economics and environmental planning and lots of other areas where we have these challenging questions that are not easily answered.
Okay, there is another question about the monarch butterfly. So actually we have not tested yet with the students. We have planned. In fact, in the month of June, we plan to have a teacher training program, a workshop for the teachers, and then we thought that this can be implemented in the schools. But unfortunately, because of the COVID, we were not able to conduct that workshop. So, but this is our next step to implement that and to test the effectiveness and what kind of differences we can find.
Yeah, I tried the monarch butterfly example with graduate students in Shanghai, and it didn't work well because in China, butterflies do not migrate. They only migrate in North America and then Australia, and then there's some in Taiwan that migrate a little bit, but it didn't resonate well. So then, so we looked at other examples. So these examples should be tailored. One of the things we want to do is figure out what the interests of a child are, and then find puzzling examples that fit those interests to engage children related to their own interests, but they should be real world examples. The butterfly example, which is something that I got interested in and ultimately couldn't answer, how they managed 4 generations later to go back to the same place in Canada.
Okay, there is a question from Baltasar asking, what is the name of the game that evaluates the critical thinking?
Okay, that is from the East China Normal University. It is not yet in the Play Store, so they have not published it. So we cannot give you the details about that game. We have tested it during last year, I think in UNT. But if it will be available, then we will definitely try to share that game.
Yeah, it did have a name, but I don't remember the name. The person who's presented it at a couple conferences is Jung Lung, and Professor Gu at East China Normal University can give an update on that. Due to lack of travel and COVID, in fact, the COVID situation is a perfect example for critical thinking, and is illustrated by the fact that so many people in my country are not thinking critically about the virus, but other people around the world are. Oops,
okay, I know you have
to watch my political comments here because my dean is here.
I know you have answered the next question, but I'm going to read it so that for consistency that it gets recorded. So there is a question from Judith, starting with, thank you for your presentation and useful explanation about critical thinking. Regarding the monarch butterflies example, I would like to know if you have tested or seen any differences regarding the development of critical thinking between doing this activity in traditional real world settings versus doing it in the immersive environment you have developed. Thank you. And then she has just added, since it hasn't been tested, any hypothesis about what could the differences be between these two environments?
Okay, I would like to add this thing. The idea behind the immersive environment is, like in the first slide I mentioned, that how we can bring real life experience to the classroom, because it is not possible for the student to see the migration of the butterflies that is possible. So that is the idea behind this. So we hope that this will bring a difference, but until unless we have the empirical research, we cannot claim this. But let's see. After the implementation, we will definitely have some results from this. Mike, would you like to add?
Yeah, no, that's good. Yeah, that you can do things in a virtual environment that might not be easily possible face-to-face or in a real-world situation. But our ideas have almost always come from actual real-world situations. And we've been testing these ideas with my grandchildren. They're our test bunnies, so to speak. They call them test bunnies in Germany, I think, or guinea pigs in the United States. And so, and then the butterfly example came from me. I was just amazed when I actually saw it happen. And I asked a colleague where they came from, and she said Canada. And I flat out, I didn't tell her that I thought she was crazy, but I thought she was crazy. And then I went inside and looked it up, and she was right. And then I had lots more questions. But usually we start out with an example we've tested with actual kids to see if they're going to work. And as I said, I tested the butterfly example with graduate students in China and found out it didn't work with them. So that one has limited applicability. It works in the United States, maybe in Australia, but not too many other places.
Wonderful. So thank you for this session. I will close this session at this point so that people have a little bit time between this and the next session, which is supposed to be break, but it is actually a folk dance ensemble. So please don't miss it. Once again, thank you, Dr. Bhagat and Dr. Spector, for a wonderful talk, for examples, and for some very concrete advice. And of course, there are more questions at this point than the answers, but that's really the purpose of this discussion, so that a lot of people start to work on this. The more people will work, the more people will collaborate, the better our research will become. So once again, thank you very much. And I look forward to see everyone in the next session, which starts in 5 minutes time. Which is a break, but folk dance ensemble. Thank you.
Thank you very much,
thanks
sir.
for the opportunity, and thanks to KK for putting this all together.
Okay, thank you very much. If you have any question, you can email us. We are every time ready. Okay, thank you.
Thank you.